All right, so this video is dedicated to trying to understand what entropy is, kind of at a very basic level. Now, entropy, probably what you've been told before as an idea of explaining what it is that you've been told to the effect that it is basically a measure of disorder, okay? We can't say that because if we just say that something is a measure of disorder, how do we quantify disorder? We can't walk into a room and say, this room has a disorder of 17 joules. There's no way for us to quantify that. Okay, so we want to get to a more basic level of what entropy is. How do we define entropy? Okay, so entropy gives us the ability to define this idea of disorder. What we're going to see is that our entropy is proportional to the number of equivalent ways a system can be organized, okay, or distributed. Okay, so the equivalent ways, which means that we haven't changed energy, we haven't changed any other aspect of it, but there are different ways that we can do that. So the more ways we can distribute maybe energy, the greater the entropy, okay? So let's look at an example of this. Let's go ahead and just say we have two atoms, okay, with a total of 3 kilojoules of energy, okay? And let's say this must be distributed over 1 kilojoule energy gaps. So we'd have 0, 1, 2, 3 kilojoules of energy. Okay. Well, we have the possibility to have one of our atoms sit at 0 kilojoules, right? The other one sit at 3. Okay. And then we can also have the possibility where we have one of them sit at 2, okay, and one sit at 1. Okay. These would really be the only two ways that we can distribute them, right? If this atom's up here and this atom's down here, it's still equivalent. Okay, we haven't just changed the way that our energy is being distributed. So we have basically two ways that we can distribute energy equivalently. We have an increased total energy or decreased total energy. Our total energy is still 3. Now what happens if we have instead, let's say we have two atoms with a total energy of 4 kilojoules. Okay, so again we're going to do with individual 1 kilojoule of energy gaps that they can exist at. They're quantized there. So again, we can have one of them sitting at 0, okay, maybe another one sitting at 4 for a total of 4. Okay, we can also see that we can distribute 1 and 3, okay, as our two possible energies. But now we also have one more possible energy distribution that we can have, one of them at 2 and the other one at 2. Okay, so now we see that we have 3 ways that we can distribute our energy here, right? Here, there's only 2 ways that we can distribute energy equivalently. We haven't changed the amount of energy available. Here we have 3. So we would say this system at the higher energy has greater entropy, more ways we can distribute it. Okay, I only gave the example of energy, but we can also talk about the way that, molecules can move, the way that they're restricted in movement. Okay, the energies that they have, the potential energies they have, the bonds they have. There's a lot of different things that come into play when we're talking about entropy. But hopefully this gives us a good clarification of how we're thinking about entropy. This idea of number of equivalent ways that we can organize or distribute our molecules or particles within a system. So we're going to talk more about the details of this class, but hope this gives you a good introduction.